All right, so I'm going to pick up from where we left off last day. So the end of last day, we were talking about composition. And we were implementing a class where there's a collection, right? So this is the combination lock class. It's got an array inside of it, right? So it's got that array where it's an array of int, right? Now, when you have an array whose type is primitive, or if you have any sort of collection, well, if you have an array whose type is primitive, then it's easier to implement this sort of thing. It's easier to implement composition with this sort of class than when the array or collection holds a non-primitive type. So that's what I want to talk about today. So I want to make a class that uses aggregation and composition. So I want to make a class that uses aggregation to hold its collection. And then I want to make the same class where it uses composition to hold the collection, and I want to show you what the difference is. All right, so there's lots of times when you're going to want to implement a class that needs a collection as a field, right? So you have an object, and that object needs to hold references to to more than one other object. Right, so using the examples from the previous slides, right, if you wanted to implement a university class, right, then that class would need some sort of collection of faculties, right? Each faculty has a collection of schools and departments, and so on and so on and so on and so forth, right? So I mean, each school or department has a collection of profs, and so on and so forth, right? You might be making a application where you're keeping track of what's being bought in an online store or something like that, or in a real store, right? And then you need a bill of sale or a receipt class, right? So a receipt has a collection of items. On your smartphone, you've got a contact list, right? Your contact list has a collection of contacts. This is not from the notes, sorry. This is from an old slide. You might, if you're implementing a student class, right, to keep track of student grades and their progress through their academic career, right? Every student might have a collection of GPAs. They might have a collection of courses that they're currently taking. And you can think of lots of other things as well, right? The example I'm using today is I'm going to make a very simple polygonal model class. So a polygonal model has a collection of triangles. I'm going to show you what this is in a moment. Right? So I'm going to assume it has a collection of triangles. In general, it's actually a collection of polygons, but triangles are easier to work with. Okay, now you're going to need a collection of some kind inside your class, right? So I'm going to need a list or a set or a map of some kind, right? For this discussion to make any sense, you need to know what is it that a collection actually has, right? So a collection holds references to objects, right? It does not hold the objects themselves, right? So if you have an array or a list, right, inside that array or list are not objects, they're references to objects. Right? So if I make an array list of dates, right, inside that list will not be a bunch of date objects, there's going to be references to date objects. So I make 3 dates, right, D1, D2, D3, and I add them to my list, right? So I add D1, D2, and D3 to the list, right? If you were to draw a little memory diagram of what's going on, right? So dates, that's your collection, right? So that's a reference to a list object, right? So that's the reference to the list object at address 200, right? When you, the dates, D1, D2, D3. So D1's a reference to a date object. It's not shown on the picture, but it lives at address 500. Right? D2 is a reference to a date, so it lives at address 600, and D3 is a reference to a date, so it lives at address 700. Inside the list are not the objects D1, are not the 3 date objects, right? They're references to 3 date objects, right? So D1 and that first element of the list, they both point to the same object. Right? If you change D1 with that reference right there, then the date inside or the date reference inside the list, well, that object also sees a change in the date. Right? So for example, if you were to make a list of points, right? And I make a point P, and I add that to the list, right? So I add the point to the list, and then I use p to change the x-coordinate of that point, right? When you run the code, so when you print out p and then you print out points get 0, so when you print out the first point in the list, right? Which one of the following do you get? Right? Well, if you print out p and you've changed px to 10, right, you're going to get 10, 0 as your first output. So it's one of the last two for sure, right? Now, because your list points, right, it doesn't hold copies of the point p, it holds a reference to the point p, right? When you change point p, the point in the list, which I'm going to get using points.getZero, that point's going to change as well, right? So it actually prints out d, right? Both points, well, there's only one point object. When you change it using either reference, right, then it doesn't matter which reference you use to print out the point, you get the same value, right? You get 10, 0 in both cases, right? So in other words, there's only one point object in this whole slide, right? And that's the one that was made when you created point p, right? So adding p to the list doesn't make a new point object. It just stores the reference in the list. Okay, so here's another example of using a collection. Well, this one doesn't show the collection. So here's a UML diagram showing some hypothetical student class, right? So if you just read the UML diagram, you see that there's a student object. And you see that the student object is an aggregation, right, of 0 or more courses. Right? So a student, presumably this is a student, they've taken in course this thing called, this thing over here, right? That's how many courses the student's taken, presumably over their time at the university. Right? So it has is an aggregation of 0 or more courses. Right? Student is an aggregation of 0 or more GPAs. Presumably these are the grades that they've gotten in their courses. Right? And they have one, it's an aggregation of one string, which is their ID, so their student number, for example. Right? You can add a bunch of fields to this class if you wanted to, so name, address, contact information, all sorts of stuff, right? And now notice on the UML diagram, you don't show the collection, right? So you don't normally show the collection that's used to hold the courses or the GPAs, right? So whatever collection you choose to use, that's considered what's called an implementation detail, right? And it's not normally shown on the UML diagram, right? So that star, so the multiplicity argument there, right? The fact that there's possibly more than one course indicates to the reader that there's some sort of collection here, right? Whether it's an array or a list or a map, I guess. Set doesn't make sense because you can take the same course twice. Okay, so here's the polygonal model class. It's more or less the same thing, right? Same idea. So a polygonal model is an aggregation of 0 or more triangles, right? Every triangle is an aggregation of 3 points, right? Which makes sense. Okay, so an example of a polygonal model is the following. So this is a polygonal model that's been shaded. Any of you who have played a 3D video game, you've seen something like this, right? In this picture here, every object that's in the picture is just made up of a bunch of triangles. So if I take away the shading and show you just the triangles, you can see exactly what everything's made of. So you can see the ground is made up of a bunch of fairly large triangles, actually. Right? That ball is made up of, again, a bunch of fairly large triangles. Same with the apple. And I guess the same with this zealot here. Right? If you go back, right, and you look at the shading, if you don't look too closely at the ball, you can be convinced that that is, in fact, a round ball. Right? In other words, it provides the illusion that this thing really is round and not made up of a bunch of triangles. Right? It's only when you look at the silhouette, so if you look at the very border of the object, can you start to tell that this thing is, in fact, made up of a bunch of triangles. Right? So this is the sort of thing you'll learn about in CISC124, the computer graphics course. All right, so I want to make this polygonal model class. Right? I want it to be an aggregation of a bunch of triangles. Every triangle is an aggregation of a bunch of points. Right? So if the model holds more than one triangle, I need some sort of collection to hold the triangles. Right? So I'm going to use a list. Right? You could use an array. Probably don't want to use a set, but you might. Could use a map, but again, probably don't want to use a map. Right? In this case, it makes sense to use a list. Right? I have a constructor that makes an empty polygonal model. Right? So a polygonal model with no triangles. So all it does is make the list. Right? So it does, in fact, make a new list. Right? So inside this, inside every polygonal model object is a list of triangles, possibly empty. Okay, we've got some methods here. So we can clear the model. So clearing the model removes all the triangles. Right? So how do you remove all the triangles? Well, you just clear the list. Right? What is the size or number of triangles in the model? Well, you just return the size of the list. Right? So here you can see how using a list object makes your life really easy when you go to implement some of these methods. Okay, now, when you implement this kind of class, you have to decide on all these ownership issues. Right? So number one, right, I've got this list of triangles. So the first question you have to ask is, does the model own its list of triangles? Right? The second question you have to ask is, does the model own the triangles? Oops, sorry. Oh, hold on. Right. So if X is your class and X has a collection in it, right? Does X own or share its collection? Right? If it owns its collection, you have to use composition on the collection. Right? If it shares its collection, then you can just use association or aggregation. Right? Now, if you decide that X is going to own its collection, you have to also ask yourself, does X own the objects that are in the collection? Right? If the answer is yes, then you have to make a copy of every object that's in the collection. Right? If the answer is no, then you don't have to make a copy of every object that's in the collection. Let's see. It's not possible for X to own the triangles and not own its collection. Right? That doesn't make sense. Right? So you cannot own the triangles but not also own the collection. Because if you're not owning the collection, someone else has a reference to the collection, which means they have access to the triangles. Okay. So in aggregation, we're gonna happily share all of the fields. We're potentially happily share all of the fields of our object. Right? So if I'm going to decide to share the collection with other X objects, right? Then when you go to implement your copy constructor, the copy constructor does not make a new list or a new collection, right? All it does, you simply assign your collection variable to refer to the other object's collection, right? So in other words, the collection for your object is just an alias for an existing collection somewhere else. So what does that look like in a constructor? Right, so here's my copy constructor for the polygonal model class. Right? So I don't write this trie equals new list or new array list. Right? I don't make a new list. I just say this trie equals other trie. In other words, the list for this polygonal model is the same list as for the other polygonal model. Right? They're both going to share their internal lists. Right? So we say that this trie is an alias for other trie. Right? Both of those variables point to the same object. Now, for all of your methods that either return a reference to your internal list, that return a reference to a list, you don't need the defensive copy here, right? Because you're happily sharing the list anyway. So if someone asks you to get the list of triangles for this object, you just return the list, right? You're going to live with the fact that anybody who gets hold of this list can now modify the triangles that are in the list or remove them, for example, right? So if somebody calls get triangles, they get the reference to your list, and then they clear the list, then all of the triangles have disappeared from your polygonal model object, right? Okay, so in a picture, right, it's a fairly complicated picture now. Okay, so I have an existing model P1, and then I make a copy using the copy constructor, right? So I make a model P2. Right? So P1, that's the model at address 200. so we go to the model at address 200. Right? Inside that object, there's a list of triangles. Right? And we see that that list of triangles lives at address 700. So we go up to the list of triangles. Inside that list of triangles, right, there's a bunch of triangle objects. There's references to a bunch of triangle objects. Right? So there's a triangle object at address 1000. There's a triangle object at address 1100, and so on, and so on, and so on. Right? If you go down to address 1000, you see there's a triangle object. If you go down to address 1100, you see that there's a triangle object. Right? Now, when we run the copy constructor, right, we make a new polygonal model object P2, right? And that object lives at address 500. So down here we go. Right? So what does the copy constructor do? Right? The copy constructor writes this try equals other try. Right? So this try, right there, equals other try, which is right here. Right? So in other words, the value that you store here is the same as the value that you store here. Because these are references to objects, right, all you're storing are the addresses of those objects. Right? So now you can see that these two polygonal model objects, they both have the same list. Right? So there's only one list. There's only two triangles in this picture. There's two polygonal model objects, but they're sharing all of their internal guts. Right? So that's aggregation. Okay, if you use that the copy constructor, like this, right? And then you call the clear method using the second model, right? When you print out the size of the second model, you expect to get 0, right? Because you called clear, right? But when you print out the size of the first model, right, you're either going to expect to see 0 or 100, right? And in this case, you get 0, right? Because when you clear the list using model P2, right? Just go back here, right? So here's P2, right? Its list is at address 700, right? When you the clear method simply clears the list, right? So it gets rid of everything that's inside the list, right? P1 refers to the exact same list, right? So when you ask P1 for its size, it asks this list for its size. Right? Now that list is empty, so it also returns 0. Right? So that one prints 0, 0. Right? Again, this is not a defect of aggregation. Right? This is simply the consequences of using aggregation. All right. So that's straight aggregation. It's the easiest one to implement because all you're doing is assigning variables. If you decide that your object should own its collection, but not the objects in the collection, right, then that requires you to make a copy of the collection. Right? So when you make a copy of a collection, but you don't copy the stuff inside the collection, that's called a shallow copy of the collection. Right? So you make a copy, so you make a new collection, but you don't copy the stuff that's inside the collection. Right? That's a shallow copy. So in a shallow copy, right, you're going to make a new collection, right? But the references in the collection, those are all aliases for references in the other collection. Right? So now you've got two separate collections, but inside they all point to the same objects. Right? So it's the same picture here, right? If you decide that you want to own the collection, but you don't want to own the stuff inside the collection, right, then a polygonal model is still an aggregation of a bunch of triangles. Right? It's not a composition because composition implies ownership. Right? If you decide that you're not going to own the triangles, then that's aggregation. Right? So it's the exact same picture it's the exact same UML picture. Right? The implementation details are a little bit different. Okay, so if I want to own the collection but not the objects inside the collection, then I have to copy the collection. Right? So I have to make a shallow copy. The hard way to make a shallow copy is to use a loop. Right? So I'm going to make a shallow copy of some list called dates. Right? It doesn't matter what's in it, right? It's just a list of dates. So to make a shallow copy, I need to make a new list. right? So scopy equals new array list, right? Now, everything that's in the copied list, I have to put into the new list, right? So one way to do that is to write a loop, right? So for each date D in dates, right? Remember, dates is the list that we're copying. I'm going to add that date D to the copy, right? So that's the hard way to do it. Don't do it this way, right? If you want to make a shallow copy, just use the constructor of ArrayList, right? So if you call the ArrayList constructor and pass in a collection, the constructor will automatically make a shallow copy for you, right? So in other words, it will write the loop for you and copy everything over. Or it'll do something that's equivalent to that, right? So to make a shallow copy, it's just one line, right? You just make a new ArrayList, pass in the collection that you want to copy, right? So list and set both have constructors where you can pass the list or set constructor a collection, and the list or set constructor will copy all the elements in that collection into the new list or set. Right? So if you ever need to make a shallow copy of a list or set, just use the constructor, right? Don't write your own loop. Okay, so in the copy constructor, well, that makes life really easy, right? So it's still almost as easy as not owning your own collection, right? You just write new array list, other try, and that copies that makes a shallow copy of the other polygonal models list of triangles. Now, the important thing to remember is there's no new triangle objects being created in this example, right? There's a new list, but there's no new triangles. Right? So now your memory diagram picture changes a little bit. Right? So if I call the copy constructor this time with the new version of polygonal model, right? I have two polygonal model objects, right? But the copy constructor makes its own list, right, for the second polygonal model object. Right? So back here, right, we make a new list. Oops, sorry. Right? That means this try has to point to a different list than this object, than the copied object. Right? So the original object, its list is up here. Right? The copied object, its list is right here. Right? But everything in the two lists are identical. Right? So the first model has a triangle at address 1000. The second list also has a triangle at address 1000. Right? It's the same triangle. They both point to this triangle down here. Right? The first list has a triangle at address 1100, and the second list also has a triangle at address 1100. So they both point to that object there. Right? So you have two polygonal object models, two lists, but still only two triangles. Right? You haven't made any new triangles in this case. So this object here, this polygonal model object, does not own these triangles. Right? This model does not own these triangles. Right? They own their own collections, but they don't own the triangles in the collection. Okay, so using our new copy constructor, I'm going to make a copy of some other model. Right? If the first model has 100 triangles in it, what does this code print? Right? So P2, make a copy of P1. Right? Then clear the list of triangles using P2. Right? So when you print out the size of P2, that had better be 0, right? Because I've cleared the list of triangles. Right? But what's the size of P1? Right? Well, the size of P1 is 100, right? Because you have two separate lists. Right? So when you use P2 to clear its list, it clears this list. Right? P1's list does not change, right? That's P1's list. So its list doesn't change. So as far as P1's concerned, it still has 100 triangles in it. Right? But P2 now has no triangles in it. Oops, sorry. Right, so there you should get 0 and 100. Same question, except the code's a little bit different now. So make a P2 is a copy of P1. Right? If I ask model 1 for its first triangle, right, and if I ask model 2 for its first triangle, right, are they the same triangle object? Right? So T1 equals T2 means, is T1 the same object as T2? The answer is yes, right? Why is it yes? Because the first triangle object for the first triangle for P1 is up here. The first triangle for P2 is right there, and they both have the same value, right? In other words, they both point to that object there, so it's the same object. Equals equals returns true, right? If you change that to dot equals, it should also return true, right? Because it's the same triangle. Okay. All right, so now we're in situation number 3, right? Now I want X to own its collection, and I want it to own everything inside of its collection, right? So for the polygonal model class, this means I want a model to be a composition of triangles, right? So the only way you can do this is by deep copying the list of triangles, right? So a deep copy of a collection means you make a new collection, right? So if I want to make a deep copy of a list, I make a new list. And then I have to deep copy everything that's inside the list, right? So I have to make a deep copy of all of the elements that are inside the collection. Now, if you have a collection of collections, so if you have a list of lists, or if you have a list of maps, or you have a list of sets, right? To make a deep copy, you have to deep copy all of the elements, right? So now I have to deep copy every list that's in the list, right? If that list happens to be also another list of lists, then you have to go down and copy all of the lists that are inside that list, and so on, and so on, and so on. Okay, so what's inside of the new collection, right? It's a bunch of new objects, right? So the references in the collection are now references to new objects, right? So now the UML picture, the UML class diagram changes a little bit, right? So if I decide that a polygonal model should be a composition of triangles, right? So remember, solid diamond is composition, right? Now I need to make sure that all of these triangles belong to a single polygonal model object, right? So I can't share the triangles anymore. It's funny, this is a bit unusual because that triangle is still only an aggregation of points, right? It's not the triangle itself is not a composition. Okay, so if you want to deep copy a collection, right? And your collection is not a collection of collections, right? So you don't have a list of lists, it's just a list of elements of some kind, right? Then you have to make a new collection, right? So the deep copy, you start by making a new collection, right? And now you need a loop, right? There's no way, there's no method or library method. There's no library method anywhere in the Java standard library that makes a deep copy for you, right? So you write a loop, right? You loop over the collection that you're copying, right? Inside the loop, you have to make a copy of that object, of the object D. Right? So I have to make a new date, where the new date object is a copy of the date object referred to by D. Right? So new date, D get time. Right? Again, remembering that date's weird and doesn't have a copy constructor. Okay. So if you're going to implement the polygonal model copy constructor, right, you have to write some similar code. Right? I want the polygonal model to be a composition of triangles, so I need to make a new list to hold my triangles. Okay, so there's my new list. Then I have to loop over the other collection's list of triangles. Right? So for each triangle T, in the other object's list of triangles, right, I'm going to add a copy of T. Right? So I have to make a new triangle every time. Calling the copy constructor in this case, right, and add the copy to the copied list. To the copy of the list. Right. Okay, now the picture for this changes once again. Right. So P1 and P2, right? So there's their first model, there's your second model, right? The first model's list is up here. The second model's list, well, I made a new list when I called the copy constructor, right? So a new list appears in memory, right? And now the copy constructor loops over that list and makes a copy of every triangle that's in that list, right? So in the original list, there's a triangle at address 1000. There's a second triangle at address 1100. So they're right here and here, right? When you run the copy constructor, right? The copy constructor copies that triangle but makes a new object, right? So there's a new object somewhere at address 2000 that's a copy of that object, right? And there's a new triangle here at address 2100 that's a copy of that object right there, right? Is there? Oh yeah, right. So on the next slide, you can see the two new triangle objects, right? So what's happened here? Right, I've got two models, right? They each have their own lists, so there's two lists, right? Each list has its own triangles, right? So there's 2 plus 2 more, so 4 triangle objects in total, right? So now you've actually duplicated every object that's in this slide, right? There's 2 copies of everything on this slide, right? Back here, when you only copied the list, right? 2 new models, 2 new lists, or 2 models, 2 lists, but only 2 triangles, right? There aren't copies of the individual triangles. And when you just use straight aggregation, right, there's only 1 list, and there's only 2 triangles, right? And everything's shared. Okay, so if I now use the third version of the copy constructor, right, and I run this code, right? So P2 is a copy of P1, right? If I clear P2's list, right, and ask for its size, you should get 0, right? If you ask for the size of P1, well, P1's list is a different list than P2's list, right? So that stays at 100. Okay, now you run the deep copying copy constructor. Right? P1 has 100 triangles, so P2 is a copy of P1. Right? If you ask P1 for its first triangle and you ask P2 for its first triangle, right? And then you write T1 equals T2, right? Are they the same object? So are the 2 triangle objects the same? The answer is false, right? Because you made a copy, right? You've made a new copy of each triangle, so they're not the same objects anymore. But are they equal? Well, the answer is true. Right? So the triangles are equal, meaning they have the same, meaning that the coordinates of their points are the same, right? But they're actually different triangles. Okay, so the pictures are useful here. You can see right away what happens when you use composition, right? So when you use composition, everything ends up being independent, right? So this model here and this model here, they are completely independent models, right? They're copies of one another, right? In other words, they have the same, they have identical state, right? They have all equal triangles. Their lists are even equal, right? But they're independent. So if you make a change to P1 somehow, right? So if, in other words, if I try to change the triangles here, right? P2 does not see the modification that you made to P1, right? Similarly, if you modify P2, right? So I come into this list of triangles and do something with the triangles here, right? P2 changes, but P1 does not change, right? The only way you can make this happen is if you duplicate all the triangles, right? The price you pay by making this copy, right, is that you've now used up twice the amount of memory that you had before, right? So when we just had the one object here, right, I needed the memory here, here, and for the triangles, right? When I make the copy, I need the memory here, here, and the memory for its new triangles, right? So you just doubled the amount of memory that you needed. When you just copy the list, so when you make a shallow copy of the list, right, you also need more memory because you now need a copy of the list, right? You don't need as much memory because you're not copying all the triangles, right? So this one's not quite twice as much memory. And when you use aggregation, right, you use almost no extra memory, right? All you need is the memory to hold this thing here, which is just one field, right? It's only got one field in this class, right? So there's almost no extra memory being used here, right? There's no new objects being made either, which means the garbage collector doesn't have to clean up all of the extra stuff that's associated with the new object, right? Because there is no extra stuff associated with the new object, right? So that's why you use, that's one of the reasons why you use aggregation, right? Even though the two objects are not really independent anymore, right? If you change that list, both objects see the change. The objects aren't independent, but the amount of memory that you use, you don't use very much more extra memory, right? As soon as you start copying stuff, right? So for example, when I duplicate that list, right? I now have to duplicate all, I now have to use twice as, I now need extra memory equal to the size of the memory of that list, right? And when you go for full-blown composition, right, you double the amount of memory needed, right? So when you copy an object, you really are copying everything inside of it, so you double the amount of memory that you're using. Right? So that's the main drawback in composition, right? You have to pay for the time and the memory needed to make all of these copies, right? And you may not always be able to do that. Okay, so we've done that, we've done that. Okay. It's 10 after, so I'm just going to stop there. So the next lecture, we're going to start moving into interfaces. So interfaces and inheritance is the next topic in this course, right? And that's going to take us through for another 2 weeks-ish. And then the rest of the course, we're going to talk about something called generics. So I'm going to show you how to implement all of the, well, not all of them. I'm going to show you how to implement some of the data structures that you've been using in this course. All right. I think your midterms are marked. I just have to double check to make sure that everything's been done correctly. But you should be getting those back shortly. So sometime tomorrow, today or tomorrow, you'll get back your marks for the midterm.